All right, now I'm going to use shells with one where we're rotating around a line that's not the axis. Here, we're supposed to find the volume of the solid generated by this guy, which is some upside down parabola, and y equals 3. So if I draw this, you can figure it out pretty easily. Like it goes through 0 and 4. And so then the top is at 2, right? So, and if I put in x equals 2, I get 4. So it starts here. This is the line y equals 3 is going to be here. And so it's going to be here. So I've got this little region here. I'm going to get rid of this line. Right, but this is y equals 3. And what it wants me to do is rotate this around the line y equals 1. No. That would be different. We can do that too. But we're going to rotate it around the line x equals 1. So that's going to be this line here. We're going to rotate it around here. So you can imagine this is just going to kind of go like that over here somehow. Okay, now technically I should be careful and make sure that I drew it properly. So let's double check that this makes sense. What points do these two curves actually intersect? I'm going to have x squared minus 4x plus 3 equals 0. So I can see I've got x minus 3 and x minus 1. So yes, the two curves do intersect exactly here at 1, 3 and 3, 3. So that's my x. Now if I draw this as a shell, I'm going to imagine there's my shell, right? That's my cylinder around my axis of rotation. And so if I think about what this is going to be, I can see that, all right, wait, I forgot to write my formula, right? It's going to be 2 pi integral radius times height times d thickness. All right, so, but now the radius is going to be shifted over because rather than going from the point is 0, from the axis, the radius is going to always go from the axis of rotation, right? So this is going to be my radius here since I'm no longer around the axis. It is going to be something about x, but it's not going to be x. Because if I do x, right, x is going to take me all the way out to here. So this is x. I know this is 1. So this is my radius here. So it looks like the radius is x minus 1. So that is exactly what it is. Right? So this whole thing out to here is the point at x. And so I'm going to be integrating with respect to x. We'll fill out the height in a minute. Dx, whoops, but I need the radius is going to be x minus 1. And I have probably enough space there. And then my height and my dx. Okay, so anytime you're going to have it moved, then the radius is going to have to be shifted. So it's just a shift, okay? You do want it to be a positive number, right? So kind of keep that in mind. Let's see. So I've got radius, I've got thickness. Now and then since I'm here, I just did it, right? You can see that, in fact, you can even think about it this way, right? So my x values are going to go from 0 to 3, right? Because that was those were the points that I had solved for. My x value is going to go from 1 to 3 because those are the points that I solved for. So I'm trying to say two things at once, right? So those are the points that we solved for, x going from 1 to 3. Notice that my radius, though, because my radius is x minus 1, the radius starts at 0 and then it goes to this, which would be 2. And that makes a lot of sense because you can see that we wrapped it around this line and it's touching here, right? So the two parts of my whatever shape it is, it actually touches in the middle. So it makes sense to think about that way as well, if you want. Anyway, we can just see it from the graph that our original shape before I started drawing all this stuff on it, right, we went from 1 to 3. Okay, the last thing I need to worry about is the height. So again, the height is going to be in the y direction. All the way up to this curve is, of course, to this curve y equals 4x minus x squared, but I don't want it to go all the way. I want to subtract off the 3, right? So this is the height, and you can think about it as the height on the top minus the height on the bottom, or you can just think about it as I need that piece, but I'm subtracting the 3, right? So however way you want to think about it, I don't have space to write it here, but I'm taking the bigger curve minus the smaller curve, which in my case ends up being a line, right? They wanted to cut that off. Let me say again, you could do this with washers. You'd end up in your variable of integration would be y, so then you would be going y from 3 to 4, but because we're doing the shells, our variable of integration is the same direction as the radius, which is in this case the x. Okay, so this is actually the setup of the integral that we need in this case. And I'm not going to go through everything here. This turns out to be, well, at least I'll write down what I did. So this turns out to be this, and if you integrate this, the answer is 8 pi over 3. Let's see, I guess I could do that. All right, that's probably good enough, right? Yeah.